Hello students, welcome to the next lecture on the PY question series. Today we will discuss about linear transformations from the year 2011 to 2023. Myself Dr. Harish. You can simply follow my playlist on my YouTube channel Dr. Harish. The playlist is CSIR-NET. Here you can see the topic wise complete PY questions of the last 12 years such as complex integration, series, inner product, power series, linear algebra, quadratic form, testing of the hypothesis, that is the statistics part, and many more in this playlist. The objective of this lecture is we will cover all those questions related to the linear transformation. We will cover the 45 plus questions related to the part B and part C, and obviously with the help of the various shortcut tricks. So let's start with this one. So first of all, whenever you are talking about this linear transformation, the most important concept is we are talking about the basis and the rank-nullity theorem. I will solve majority of these questions with the help of these two concepts. Fine. So let's start with this one. N is a vector space of the real polynomial of degree at most 3. So first of all, always remember, if Pn is my polynomial of degree n, then the dimension of this Pn will be my n plus 1. So here it is at most 3. So what is the dimension of the n? It is my 4. So it is my 4 dimension. It is my 4 dimension. So the matrix n, the matrix S will be my 4 cross 4. Fine. What is the basis of the 3? So what is the basis? 1, x, x square, x cube. These are my basis of degree 3. Then very simple, if you firstly take the first basis, that is my 1. Fine. Substitute here, it is 1. What is the p of x plus 1 is a 1. So 1 is a coefficient, constant is 1, rest all values are my 0. So this option cancel, this option cancel. Look at the second basis. If I simply take p of x is my x, substitute here, what is that? S will be my right hand side is x plus 1. The constant value is my 1. Coefficient of the x is my 1. Coefficient of the x square is 0. This is 0. So clearly says second A option is also cancelled. Right answer is my B is the correct option. Look at this another one. A positive integer n. Pn is my state of all those polynomial of degree less than equal to n. So what is the degree of this? Degree of this is n plus 1. Degree of this is n plus 1. So the matrix T is my always firstly codomain 5 cross 4 matrix. Fine. Then what are the basis of this? 1, x, x square, x cube, and x raised to power 4. These are the basis of this here. Then your target is to be here. So your target is to find the A, third row, second column. So second column means that is a x. If I simply take p of x is my x. Fine. Substitute here. What is that? It's a p dash. So what is that? The capital T will be my x square plus integration of this x square over 2. So that is my 3 x square over 2. I can substitute the second value. Coefficient of 1 is 0. Coefficient of x is a 0. Coefficient of the x square is 3 by 2. Rest values are my 0. So what is that? A 3, second column 3 by 2. So these two options are cancelled out. Now they are talking about A33, that is the third column we are talking about here. If I simply take p of x is my x square, substitute here, it will be my 2x cube plus x cube over 3. So answer is 7 over 3 x cube. Now substitute this value here. Coefficient of x 1 is 0, x will be 0, x square is a 0, 7 by 3, 0. Now look at the answers of this. A33 is my this. So it's a 0. So you can see that. A33 is my 0. A32 is my 3 by 2. Right answer is my B is the correct answer. Look at this another one. N is my positive integer. M of R is my space of this. I can simply choose N is my 2. So what is that? This is my M2R is my 2 cross 2 matrix. Then the transformation is my M2 to M2 such that T of A is my 0. where A is symmetric or the skew symmetric, then the rank of this T. So we can apply the rank nullity theorem always. So this is the dimension of M2. Fine. What is the dimension of the M2 is 4, because it's a 2 cross 2 matrix. Now since this is the equality, what is the meaning of that? It defines my kernel, or the dimension of this will be the nullity. So what is the dimension of this? Dimension of A belongs to my M2 such that T of A is my 0. This is the matrix. I called this is my H. So what is the dimension of this H? Dimension of this H is my M2. Dimension of this is my here. So what is the rank of T? This is my 0. So the simple answer is my 0. Always apply the rank nullity theorem. Why it's a 4? Because the dimension of the M2 is my 2 cross 2. Okay, look at this one. S is the mapping from this, T is the mapping of this, such that T circle S is my identity. Fine. A very simple concept. What is the meaning of this? It means this must be my 1-to-1 mapping and T must be on 2. Then it's an identity mapping. So what is the meaning of? Now look at the option S circle T. So what is the meaning of that? S circle T means T is my 1-to-1, S must be by on 2. Where S circle T is identity. Is it given that T is my 1-1? Here S is my 1-1 is given to you, but T is any mapping. This is any mapping. So it may happen it is not 1-1. So this option is cancelled out. S circle T is 1-1 again, because T is not given to you 1-1. This is cancelled. T this is but not 1-1. T is on 2. S is my on 2 is not given to you. Again S is my, because S circle T is S is on 2, but S is my any mapping which may or may not be the on 2. So the right answer is D is my correct option. Okay, again there is N. I can simply choose N is my 2. So the mapping is my R2 to R2. Which of the following statement implies T is my bijective? Okay, very simple. What is the meaning of the bijective? It is 1-1 and it is on 2. Fine. So we all know when it's said to be the 1-1, when you prove the nullity of this transformation will be 0. Fine. When you prove it's a on 2, when you prove the rank of this matrix should be n, the dimension of this. What is the dimension of this is 2. Fine. Now you can see that it's a 1-1, nullity will be 0, but he said nullity is my, if I take n is 2, so it's a cancel. Rank and nullity both are 2, but nullity is 0, this is my 2, cancel. Here 2 plus 0 is my 2, satisfied. 2 minus 0 is also satisfied. But this result is applicable for any mapping. It is not always bijective. So what is that? If I say rank plus nullity is the dimension is my n, okay, and if I consider this one, rank minus nullity is here. So what is that? If you solve them, you will get nullity is 0 and rank is my n, which is comes to be 2. So this is my correct option. This is not the right one, because this is in journal true. This is true for all and for all the mapping, but he said it's a bijective. So the right answer is my rank minus nullity is my 2 is the right answer of the problem. So if you want to join my WhatsApp group, you can share, you can scan and join this one so that you can get your more information in my group. Let V is a twice differentiable function such that mapping is here 1-1 and on 2. So first of all, can you find the solution of this? Auxiliary equation is here. So clearly say what is the roots of this? So it's a 1 and 1 are the solutions. So what are the bases of this? You can see the bases are my x and e ki power x, e raised to power x, and x e raised to power x. Fine. Now once you know the basis, what are the dimension of the V? The bases are 2. The dimension of this is also 2. You can define the mapping from 2 cross 2. The bases are e raised to power x, x e raised to power x. So firstly, f, what is the f is? This is my f. So what is the derivative of this? F dash at 0. If I take f is my here, if I take f of x is e raised to power x, what is the derivative at the 0? 1. Second is f of 0. What is f of 0 is 1. Fine. Second is if I take x e raised to power x, what is my derivative is x plus 1 e raised to power x. So what is the value of the f dash 0? F dash 0 is my 1. What is the value of the f of 0? F of 0 is my 0. Fine. Then it's a 1 1 on 2. So when you can say it's a 1 1, when you prove nullity of this matrix will be 0. When you prove it's a on 2, if you prove rank of this matrix should be 2 cross 2 is here. So what is the rank of this matrix? Rank of this matrix is 2. So it means this is on 2. Fine. Now once the rank is there, then what is the rank nullity theorem? This will be the dimension of V, that is my 2 minus rank of T. What is that? 2 minus 2 is 0. Once nullity is 0, it means it's a 1 1. It's a on 2, it's a 1 1. So it is a 1 1 and on 2 both. Rest options are cancelled out. A is my correct answer. Always remember this simple concept. How you can prove it's a 1 1? You always find the nullity, that is the dimension of the kernel is a 0, and the rank or the dimension of the range space must be the size of this matrix. Okay, look at this one. T is my matrix which comes to be t raised to power 4 0. What is the meaning of that? This is my nilpotent matrix. Fine. T is my nilpotent matrix, and Ki is, which is nothing but dimension of kernel of Ti. Okay, which of the following is not the possible for these pairs x1, k1, k2 and so on? Firstly, you can see that there is same. It means there is no need to check for the I is equal to 3, I is equal to 4. There is no need to check. Then I can check for this pair. Fine. What is the meaning of this 3? What is the meaning of this 4? What is the meaning of this 4 is, this is a k2. That means k2 is dimension of kernel of t square. It comes to be 4. That's the meaning of this. And this means the dimension is kernel dimension is, what is the meaning of that? That means nullity of t square is my 4. Fine. So what is the meaning of that? Range space is my 0. That's the meaning of this. Okay. Now what you can do, a very simple concept. There are so many ways. Firstly, can you think about if I simply take rank of T is my 1. What is the meaning of that? If I simply take this matrix, clearly say this is a nilpotent matrix. Fine, because T square is also 0. Fine. Once you say this is there, what is the rank of this matrix? Rank of this matrix is 1. Nullity of this matrix will be 4 minus 1, 3. What is the meaning of that? I can take as a t raised to power 1. So k1 is equal to 3 possible. So this is a possible, but we need a not. So this option is cancelled. Now when it will be 1, when it will be nullity will be 1, when you consider the rank will be 3. Fine. Only this happens, nullity will be 1. Fine. Now then we can find the t square, that is my k2. What is the rank of the t square? I can always say this is rank of t plus rank of t minus of n. Why? What is the rank of a comma b, which is always greater than rank of a, rank of b minus n. So what is the rank of the t? I assume it's a 3. Okay, for the second pair it's a 3 plus 3, dimension will be my 4. It is my greater than 2. Once the dimension rank of t square is my greater than 2, what is the nullity of the t square? It is less than of 4 minus 2. That means k2 must be less than or equal to 2. What is the k2? Second pair. So k2 can never be 3. Fine. So this option is cancelled out. This option is cancelled out. Now we can check about whether the k1 will be 1 or 2. Again a very simple, again I can consider the same kind of the example. I can say, if I simply take the matrix to be here 0 0 0 0 0 0 0 1 0 0 0, then rank of T will be 2, nullity of this will be 2, clearly says T square will be my 0. So what is the meaning of that? The 2 is possible. So this option is cancelled, this option is cancelled. Only option left is my B is the right answer. Look at this another one. Which of the following is a linear transformation? Very simple. F of 0 must be 0. Fine. So this option is cancelled out. Because what is the f of 0? It is 4, 0, which is non-zero. So A option cancel out. Only F cancel. All the transformation cancel. Clearly says this x, y, the degree of this term is my 2. This implies it is my not linear. Fine. So it means G also cancel. Only left option is my C. That is the only H is my linear transformation. Okay, for a positive integer n, f of n is my polynomial. Okay, again similar. What is the degree of this? 3. Degree of this? 5. So the matrix will be my 5 cross 3. 5 cross 3. So now you can write the basis of degree here. X, x square, x cube, x raised to power 4. Then you have to find the polynomial of x square. If I simply take p of x is my first 1, then this value is also 1. The coefficient is my here. If I simply take p of x is my second is x, then this value will be capital T is my x square. So this value will be my 1, rest values are my 0. If I take p of x is my x square, then this value will be my x raised to power 4. This value will be 1, rest values are my 0. If I take x cube, what is the degree of this? No, what is that? Yes, it's a 5 cross 3. So it's a 5 cross 3 matrix complete. Now what is that? What is the rank of this matrix? If I call this is my T, what is the rank of this matrix? There are 3 non-zero rows. Rank is my 3. Rank means that is a range is my 3. So this is there, this is cancelled. Range is there, this is a cancel. It is not a linear transformation. Cancel out because it's a linear transformation. So the right answer is my only B is the right answer. Again, it's a polynomial of degree 10. So we can construct a matrix. Fine. But from V to V. So what is the dimension of the V? 11. Dimension of V is 11. So this is my 11 cross 11 matrix. So what are the elements? 1, x, x square up to x raised to power 10. What is that? Consider the basis of this. Okay, the mapping is T of Px is my P dash of x, which is given to here. Now you can think about here. If I simply take 1, what is the derivative is 0. So that's the constant part. So all are my 0. If I take x, the derivative of x will be 1. So which is a constant 1, rest values are my 0. If I take x square, the derivative of x square is my 2x. So coefficient of x will be my 2, rest values are my 0. If I take x cube, the derivative will be 3x square. So it is my 3, rest values are my 0. And so on. So 1, 2, 3, rest will be 9. So if I take as a 9, 9x cube. Fine. So the coefficient of the 9 is here, rest values are my 0 and so on. Fine. So clearly says this diagonal values are my 0. So all these eigenvalues are my 0. What is the meaning of that? Trace of this matrix A is my 0, but he said 1, which is not equal to 1. First option is cancel out. Determinant is a 0 because each eigenvalue is 0. So the determinant is a 0. Correct answer. There is no m. so that a raised to power m will be 0. What is that? If all the eigenvalues are 0, it means this is my nilpotent matrix. So once this is a nilpotent matrix, definitely there exists a m which such that this property hold. But he said no, cancel out. A has the non-zero eigenvalue, but all these eigenvalues are my 0, has a non-zero eigenvalue. Right answer is B is the correct option. Okay, let's see is the basis of the R2, then the mapping is defined like here. That's very simple. I can find the values of these bases. Fine. What is that? When you take 1, 2, it is 2, 1 plus 3. It is 1 minus 4 is a minus 3. Then if you take 2, 1, it is my 3. It's a 2 minus here. Fine. Now there are the two methods. The first method is you can write this element like 3 minus 3 in the terms of bases 1, 2 plus b times 2, 1. Similarly 3, 0, it is my a times 1, 2 and b times 2, 1, and find the values of a and b. Fine. Or if I already written that this is say C and D. Fine. Find the A, B, C, D, then you can get as a matrix. But that will take a 2 by 2 matrix. Otherwise, the easiest way is I can pick the first value. I can pick the first value. I can multiply this by 1 by 2. Check whether this number is 3 and minus 3 or not. Like if I take the first value as a minus 3, multiply this with the first pair 1, 2 plus second value is a 3, multiply with 2, 1. What is the answer is minus 3 plus 6, 3. Minus 6 plus 3, minus 3 is satisfied. Look at the second pair, minus 2, 1, 2, 1, 2, 1. So it's a minus 2 plus 2, 0, but we need a 3. So first option is cancel out. Look at the next pair, 3 and minus 3. If I multiply this by 1, 2 and this by 2, 1, can it be 3, minus 3? 3 minus 6 is a minus 3, but we need a plus 3. So this option is also cancelled out. Look at this pair, minus 3 and 3, it is already satisfied. We will check about minus 1, 1, 2, plus of 2, 2, 1. So what is that? Minus 1 plus 4, 3, minus 2 plus 3, 0. It's both are satisfied. This is the right answer. Look at this one. Again, 3 and minus 3, the first pair, it is not satisfied. So this option is cancelled. C is the right answer of this problem. Look at this another one. V is a vector space. So T is a mapping from P2 to the P3, where P are my polynomials of degree less than or equal to n. What is the degree of this? 3. Degree of this 4. So this T is my 4 cross 3 matrix. Fine. So look at, this is not a 4 cross 3. This is not a 4 cross 3. If this is the 4 cross 3, then the bases are my, what are the bases of this? 1x, x square, x cube. The basis of this is 1x, x square, x cube. What is the function is? T of f is integration from 0 to x, f plus f dash. Fine. Now look at these. The first column are same, so there is no need to check. I can check for the second column. That is, if I take f is my x. If I substitute here, what is the integration of this? X square by 2. This is my 1. So there's a coefficient 1. Fine. X square is my half, rest are 0. That's the correct statement, because this is my, you can see that this is wrong option. If you want to check for the third pair also, then I can take the x square basis, substitute here, it is x cube by 3, derivative of x square will be 2x, and you can see 2x, coefficient of the x cube is 1 by 3, so the right answer is my B is the correct option. Always remember, you have to firstly define the dimension of the problem, so the rest of the options cancel and you can make it easy calculation. Okay, let's see. Capital T is the mapping from the complex to the matrix defined like here. Which of the following statement is my false? Okay, first one is here, which is for all. It is for the all values of this. So what is the easiest way? I can simply take Z1 is my 1. I can return this number in the form of complex number. I can take also the Z2 as here. Fine. So what is the Z1 into Z2, which is again a 1. Fine. So what is the value of T of this? If I substitute here, what is that? What is the meaning of that? It is x plus x is my 1, y is my 0, y is my 0, x is my 1. Fine. Which is nothing but identity. Then what is my T of Z1? Z1 is my here. If I substitute here 1, 0, 0, 1. Same which is of the Z2. So look at that. This is I, this is I, this is I. Which of the following is false? But this is my true state. Similarly, if I look at this, because I take Z1 and Z2 are same, so this is my 2 of I, because this is, what is the Z1 plus Z2? It is my 2. 2 plus iota 0. So what is that? This number. This number will be my, x is my 2. Fine. Y is my 0. Y is my 0. So I can also return this is my 2i. So this is also my true statement. But we need a false statement. T is singular if and only if Z is 0. What is the meaning of the singular is? This is singular. What is the meaning of that? Determinant of this will be 0. So what is the determinant of this? That is x square plus y square is my 0. If x square plus y square is 0 only when x and y both are 0. When x and y both are 0, it means z is my 0. And they are talking if and only if I consider z is 0, it means x plus iota y is 0. This is 0 only when x and y both are 0. So this is 0. So this is also my correct statement. So the only thing is my, this is my left is my false statement. But if you want to check how it is a false statement, there does not exist any A such that the trace of the matrix T and A is 0. So it means he said there does not exist any of the matrix A. Look at that. A very simple. What is the trace of the matrix A? X plus x, 2x. So if I consider, can I consider this matrix whose trace will be 0? Fine. Then what will be my T into A? If I multiply this value will be here, the diagonal will be x and minus x, whatever here. What is the trace of this matrix? 0. So it means there exists at least one matrix, but he said does not exist. That's why this is a false statement. So right answer is C is the right answer. Look at this, another one is a finite dimension vector space. T1 is a mapping from V to V, W to W such that the minimal polynomial of this. The minimal polynomial of the F1 is given to you. Minimal polynomial of the F2 is given to you. Fine. F1 is corresponding to the T1. F2 is corresponding to T2. Capital T is the mapping from the direct space to the direct space. Fine. Such that T of V is defined to be here. F of x is the minimal polynomial of capital T. How you can find the minimal polynomial of this? If you know the minimal polynomial of this is my F1, minimal polynomial of F2 is my here, can you find the minimal polynomial of this? Oh, very simple. You can find the minimal polynomial by using the LCM of minimal polynomial of F1, minimal polynomial of F2. So you can find this. So can you factorize this? I can return this is x square plus 1. This is x plus 1. This is a factor of this. Can you do the factor of this? It's a 2 and 1. So you can easily factorize this. This will be my x. I can return as a 2x square plus x square. Fine. So it is my x square minus of 2 and x square plus 1. Fine. So what is that LCM of this? Can you find the common factor? Is a x square plus 1, one term, and x plus 1, fine, and x square minus 2. This is the minimal polynomial of this f of this capital T. So what is the degree of this? Can you look at that? Degree is my 5. So the right answer is B. This option is cancelled. Now you have to find the nullity. How you can find the nullity? Whether it's a 1 or 0. What will happen if it is 0? It means it is my 1 1. Now look at that. You can find the rank. If I found the rank of the matrix T, then I can use the rank-nullity theorem. We can find this. What are the eigenvalues of this? It is my plus minus iota. It is my minus 1. It is plus root 2 and minus root 2. You can see all are my distinct eigenvalue. Fine. So what is the meaning of that? If they are distinct eigenvalues, what is the meaning of that? Rank of this matrix is the number of the distinct elements, that's a 5. If rank is my 5, what is the nullity of this? By using the rank nullity theorem, 5 minus 5 is my 0. So this is my here. So that is right options are B and D are my correct option of this example. Because you can easily see the dimension of this. What is the minimal polynomial degrees? You can see W plus is a minimal polynomial is degree 5. So its a dimension is my 5 minus rank of this. Okay, look at this one. A, B, C, D are the real numbers, is a mapping. Capital X is a complex number to this. Then S is always C linear. C linear means if linearity property is satisfied. C linear if this property is C linear and here. Again, very simple. You can start from here. I can simply take Z1 is x comma y. So I can simply take the basis as 1 comma 0. Z2 is my another basis, say 0 comma 1. These are the bases of R2. Remember, whenever you are working on the linear transformation, try to think about the basis. So what is my here? So what is the S of Z1 plus Z2? This is S of 1 comma 1. What is the 1 comma 1? X is my 1, Y is my 1. So what is that? This is okay. A, B, C, D can have any real number, so I can choose them for the sake of simplicity. A is my 1, B is my 0, C and D also are 0 for the sake of simplicity. So we can see what is that? This is A is 1, X is my 1, B is my 0, is a 0, C is my 1, C is my 0. So this is also 0, this is also 0, that's a 1. If you look about the right hand side, what is the S of Z1? Z1 will be my 1 comma 0. So X is my 1, Y is my 0. Y is my 0, C, D, so it is my 1. Similarly, this, it is my 0 comma 1. So what is the 0 comma 1? X is my 0, so this part will be 0. So you can see they are, sum will be equal. Okay, then what is the product? S of alpha Z. Alpha Z means I can take any of the Z, alpha X, alpha Y. So can you say this is equal always? It is alpha times AX because B, C, D are my 0. Can you say this is my of this? Yes, it is true. This is true. Fine. But can it be true for all the alphas and all those Z is equal to C? We can see that because this is the one counter example I have taken this pair, and moreover this is one particular example, so we can't say. So in journal we have to prove in journal. So how you can see, look at that. If I simply take Z1 is my x1 plus iota y1, Z2 is x2 plus iota y2. So what is the S of Z1 plus Z2, which is nothing but A times x1 x2 plus B times y1 y2 plus iota times similarly of this. What is the S of Z1 is this one. If I add them, addition property is satisfied. Can you say for the alpha into Z also? So it is alpha x plus iota alpha y. if I substitute here, it is my alpha will be common, so it is satisfied. It can be written as here S of Z. It is satisfied for S is linear. So now, so you can see here alpha is my C, so I forget to take it as a C. Alpha from the C, so I can simply take alpha is my C, that is iota, which is a part of the C. Then we can check about this. So that's a iota into Z. So what is the Z is? Iota times x plus iota y, which is nothing but minus y plus iota x. Fine. I can consider same thing. A is my 1, B, C and D all are my 0. So what is the value of this? Now this is my x according to this. So A, B, C, D and all are my 0. So this is A times x. X will be my minus y. Then I can simply find the alpha of Sz. Alpha is my iota. S of Z will be x plus iota y. So what is that? Iota times A x. A is my 1, so it is my iota x. But from here it is my minus y. Clearly says both are not same. So this option is cancel out because this property is not satisfied because of this complex number. Similarly, if and only if T is the identity mapping, okay, we will see it later. B is equal to minus C. I can choose the two numbers, say B and C both are 0. Fine. A and D both as a 1. Fine. The first property is satisfied. There is no worry about that because it's a linear. There is no worry about the linear. We can check about this property. S of, again, alpha I can choose as a iota, for example. So it's a iota times Z. So that is my minus y plus iota x. Now in this case B and C are my 0. Ax, x will be here, so it is a minus ay, fine, plus iota into dy, y will be my x, fine. I can substitute a and d here. On the other hand, it's a iota times of this, it is this is a ax plus iota dy. So clearly says if I open this, it is my minus dy plus iota ax. So from here what you conclude, it is true only when a is equal to d. So this means I consider b and c are same, or you can say these are same and these are. So definitely this is my correct option. Similarly, S is a C linear only if, that means this is the if and only if, fine. So this is the right answer. If and only if T is the identity, this is the counter example. I can choose A and D are same, but B and C are opposite direction. That is a 1, 1, minus 2 and 2. Clearly says this is not my identity. So this option is cancelled. B and C are my right answer of this problem. Look at this another one. T1 and T, okay, firstly I can choose N is my 2, is a mapping from this. So these are the mappings from R2 to R2. What are the basis of this is here. So can you think about any of the basis of the R2? The bases are 1, 0, 0, 1. Fine. Suppose T1 of the first basis, that is a 1, 0, and the second one is T1 of second basis is my non-zero. So it can be anything. Fine. Then xi is a kernel of T2 as invertible of this. Very simple. Can you think any of this matrix here, because it's again the part of the R2, can you think about the matrix here such that this is invertible, so it is not invertible? Very simple. I can choose this matrix, say 3, 0 and this says 4, 0. What is the matrix associated with this? 4, 0. So the matrix is my A. So clearly says determinant of A is my 0. What is the meaning of that? The T1 matrix, the matrix A associated with the T1 is not invertible. Fine. So A, this is invertible, cancelled. Both are invertible, cancelled. Now look at the second option. Xi is orthogonal to the T2. Xi means that's a basis. What does it means that? That means kernel of this will be 0. Fine. So what is the meaning of that? When kernel will be 0, what is the dimension of the nullity? Nullity will be 0. So what is the meaning of that? Once is a nullity is 0, it means T2 is my 1 1, or you can say it is my invertible. That's the simple route I told you. So T2 is my invertible. This is the right answer of this problem. Now look at this one. R is a vector space of all the real polynomials. Capital D is my Rx to Rx, such that df is my here. Okay, this is the mapping for all those f. F is belong to the Rx. Rx is a real polynomial. Then D is my 1 1. Okay, so it means your target is to prove D of f1 will be D of f2 if and only if f1 is equal to. So clearly says, because it's the derivative, I can simply choose is a real polynomial. I can choose here. So what is the D of f1? 0, which is also 0. But clearly says f1 is not equal to f2. It means it is not 1 to 1. So this option is cancelled. There is a onto. How you can say about the onto? It means we can choose any polynomial from here. Okay, that's very simple. If I simply choose a polynomial is 1 plus x, which is in the domain of this. Fine. Can you find another polynomial, say say g? Can you find any of the polynomial so that it will satisfy this one? You can see, we can integrate them. If I choose the another polynomial as x plus x square by 2, so this is my g. Fine. If I take this is g, what is that? This is nothing but f. If I take the derivative of this, it is my f. So it means this is my onto. This is satisfied. There exists. Remember, there exists. So you have to provide only one example, not for the complete. There exists e, any function e, such that d of ef is my f. What does it means? That means derivative of this will be my f. When it will be possible? If I simply take e is my integration. Fine, because derivative and integration will be cancelled out. So e is a mapping from Rx to Rx, which is a integration. So yes, there exists a e. E is called as integration. So it means this is also the right option. Now look at the last one. Is the reverse is also true? That is e of df is my f. What is the meaning of that? E d of df is my f. Can you think about any of the function e? You can substitute here so that it will be my f. Clearly e is not my integration, because integration and this will not cancel out. Fine, because if this happens, what will happen? If you think about e is my integration, fine, then what will happen? If I use the derivative on the both side, it will be my here. Fine, if you take e on this side, it will be the derivative. What does it means? That it is my 1 1. That is a capital D is my, what is that? This is my d of f, and I call this is my here. What is that? This is a 1 1, but we already proved it is not a 1 1. So this option is cancelled. B and C are my correct options. Okay, V1, V2, V3, V4 is a non-zero vector space. The mappings are given to be kernel of phi1 is my 0. What does it means? That nullity of phi1 is my 0. Fine. What does it means? We are talking about the range dimension. So what is the range of phi1? Range of phi1 is nothing but dimension of v1, because phi1 is mapping from v1. Fine. Now what is that range of phi1 is? Kernel of phi2. Fine. So how you can find that? I can return this as dimension of phi2 is v2 minus range of phi2. Fine, by using the dimension rank-nullity theorem. Now what is the range of phi2? Range of phi2 is nothing but my kernel of phi3. How you can define the kernel of phi3? Again by using the rank-nullity theorem. Phi3 is the mapping from v3, dimension of v3 minus range of phi3. Fine. So what does it means that? And I need the dimension. So you can see dimension of v1, which is equal to dimension of v2 minus dimension of v3 plus range of phi3. But you can see the range of phi3 is nothing but dimension v4. So what is the dimension of this? I can say this is my dimension of v4. That means v1, if I open this one, what is this? It means it's a 1 minus dimension of v1 plus v2 minus v3 plus v4 is 0. Can you say this one? What is that? I written dimension of v1 as a v1, v2 minus v3 plus v4. Can you say this is 2? Minus v1 I can return here. Yes, this is satisfied. Look at this one. I start from the 2, so it is my v2, then minus v3 plus v4, sorry, minus v4, v2, yes, plus. It is always greater than 0. So you can see this value is nothing but v1, but v1 is the dimension, and dimension can never be negative. It is always greater than 0 is also the right answer. Look at this one. When I substitute 1, it is my minus v1 plus v2 minus v3 plus v4. It is less than 0? No, it is equal to 0. This option is cancelled out. Look at this one, which is said is not equal to 0, but is equality 0. So the right answers are my A and B are my correct options. Now look, you can think about this. Okay, fine. Now look at this next one. V is a finite dimension vector space over this such that rank of t square, which is equal to rank of t. Okay, so it's a finite dimension. So I assume dimension of V is my finite dimension is say 4. Fine. Or you can consider as a n. So what is the meaning of that? By applying the rank-nullity theorem, it is my kernel of t square. It is 4 minus kernel of t. So what does it means? The kernel of the t square is nothing but kernel of the t. Or you can say instead of this, that's a nullity. It's a nullity. So what is the meaning of that? If nullity are same, it means the dimension of this is also same. It means because it's a finite dimension vector space, so it means kernel of t square is my here. Now since rank is my t square and both are same, so once the rank is same, so it means that dimension of this is also same, which is nothing but the range of this, so which is also the correct option. Look at this third option, that is the intersection of this. Very simple. If I suppose x belongs to the kernel of the t intersection range of the t, what does it means? It means x belongs to the kernel of the t. Because of this intersection, x belongs to the range of the t. What is the definition of the kernel? T of x will be my 0. What is the definition of this range? There exists some y such that t of x will be my y. Fine. Now again, if I apply that because it's a finite dimension, so I can apply that transformation t on the both side. Again it will be my here. Fine, because it's my linear. So what is the t square y? It is my t square x, and it is t square y, and it is my t of y. So what can you say about this? Your target is to prove x as a 0. What is the value of the t of y? How you can say t of y? How you can prove that? Okay, I can start from here. If I apply the transformation on the both side, t of x will be the t of 0. T of 0 is a linear transformation here. So it's a t square x will be 0. What does it mean? x belongs to the kernel of t square. Fine. If x belongs to the kernel of t square, then t square x will be 0. So this value will be 0. So if this will be 0, then t of y will be 0. What does it means? No. My target is to take as x and prove x to be a 0. Fine. So okay, from here you need y is belongs to the kernel of the t. Fine. But yes, fine, over. Once, because kernel of t is nothing but the kernel of t square. What does it means? T square y will be 0. T square y will be 0. If kernel of y is 0 or t of y 0, we can say x will be 0. How you can say it will be 0? T of y will be 0 is a t square will be 0. Sorry, that's wrong. It's a t of y. I can repeat here. X belongs to the here. This means t of x will be 0. There exists a y such that t of y will be my x. I wrongly written here. This is wrong. Okay, then I apply that transformation on the both side. So t square y is my t of x, but t of x is my 0. It means y belongs to my kernel of t square. If y belongs to the kernel of t square, and kernel of t square is nothing but kernel of t, so what is that? T of y will be 0. So if t of y is 0, it means x will be 0. So that means this number will be 0 is the correct option. And the last option is obvious test, because the kernel of t is nothing but the t square. I can replace here. Range is also same. So it's all are my correct option for this example. Here I written wrong because there exists y in the range. So t of y will be x. I written as a wrong here. Okay, look at this one. V is a vector space of degree less than or equal to n. I assume n is my 2. It means dimension of V. It means V is a vector space of all those polynomials of degree less than or equal to 2. What is the dimension of V? Is my 3. Then P of x will be a0. N is my 2. It is my a1 x. I can simply choose n is 1, so that it becomes simply a1 x. Fine. Then the dimension will be my 2. Fine. Capital T is the mapping which are defined from P of x to n is my 1, so it is my a1 plus a0 of x. Fine. So what is that? It has a value 2, dimension 2, it has a dimension 2. So you will construct as a 2 cross 2. The constants, what are the bases of this? Bases are my 1 and x. Fine. If I take P of x is my 1, I can return here. So 1 is my a1. So a1, a0. If I take as a x, fine, so x will be my a0. a0 is my here, and this is. Now look at that. T is 1, 1. I have to prove rank of this will be my n. n is my 2 cross 2. Dimension is my 2. T is on 2. I have to prove kernel of this will be my 0. T is invertible means I have to prove determinant of this will be non-zero, and clearly says determinant will be non-zero. So this option is correct. Determinant is my plus minus 1. What is that? Determinant is minus of 1. Okay, firstly, what is the rank of this? Rank of this is my 2, which is the n of this size. So what is the meaning of that? This is my 1, 1. Sorry, this is reverse. This is above, this is below. So this is means this is my on 2. What is the nullity? Nullity is my 2 minus rank of this. It's a 0. It is my 1. Fine. This means t is on 2. This is my t is 1, 1. This is the correct option. This is the correct option. Now determinant, you can easily see that determinant is a plus minus 1. Is here is the right answer. So all are my correct answer of this problem. Okay, again it's here. I can choose n is my 1, but if I choose n is 1, then both options are same. So I can choose n is my 2. so that options are my different. So what is that? V is a polynomial of degree less than or equal to 2. Dimension of the V will be my 3. Fine. So is a 3 and 3. So you have a 3 cross 3 matrix. What are the bases? 1, x, x square. If I take 1, the derivative 1 is a 0. If I take x, derivative of this will be 1, is a constant 0. If I take x square, derivative will be 2x, but at the point 1, this value will be my 2. So this is constant is 2, rest all are my 0. Fine. So now once you can get this matrix, what does it means? You can see rank of this matrix, T is my 1. Kernel of this matrix will be 3 minus 1 is my 2. So rank is my 1, n is my 2. So this number is 2, this number is 3. Rank is my 1, so dimension of the range is my 1. B is the correct option. Kernel is my 2, dimension of the kernel is my 2. Dimension of the kernel is cancel, is a 3, cancel. A, B are my correct answer of this problem. Okay, look at this are the, again I can choose n is my 2, then A1 and A2 and B1 and B2 are the two bases of the R2. P is my 2 cross 2 matrix such that AIs to the BIs, where AI and BI are the standard bases. Okay, so you can choose A1 is say my 1, 0, this is 0, 1 or any of the two Li. Fine. Suppose for every eigenvalues of the P, eigenvalues of the P are either 1 or minus 1. Q is defined to be I plus 2, P. Then which of the following is there? Firstly, we can check about the eigenvalue of the Q. So what is the eigenvalue of the 1 is 1, 1. Eigenvalue of the 2P is 2 or minus 2. So right answer is 3 or minus 1. These are the eigenvalues of the Q. So eigenvalues of the Q are either 3 or minus 1 is the correct answer. Q is invertible. So we all know the determinant of Q is nothing but product of the eigenvalues. The product of eigenvalues is my minus 3, which is non-zero. So this is invertible, also correct option. Determinant of Q is my greater than 0 if determinant of P is my positive. So it means I have to take either eigenvalues are my plus 1 only or minus 1 only. If P has eigenvalue plus 1, what is the eigenvalue of the Q? 1 plus 2, 3, which is a positive. If I choose the eigenvalues are my minus 1 and minus 1, then the eigenvalues of the I plus 2P, it will be this is 1, 1, it will be minus 1, minus 1, and again see that what is the determinant of Q is a plus 1, which is a positive, and determinant of the P is also positive. So it means this is also the correct answer. Now look at this another one, that's the A option. Now they are talking about the basis. What is the basis means? They are Li. Fine. Okay, we all know if T is a mapping from A to B, fine, T is a mapping from A to B and it is 1, 1, fine, then T maps from Li set to the Li, that is we all know. So it means now they are talking about the dimensions of the V. So A plus 2, that means firstly you try to prove Q is my 1, 1. We already proved that because the determinant of Q is my non-zero. So what is the meaning of that? Q is my 1, 1. So once is a 1, 1, so we can map. So what is the basis of this? So if I take any of these bases, say AI, fine, these are the bases of these Qs, fine. So if I look at this, what are the bases of this? You can see about that. That means AIs, because this is my A plus 2 of BI, because P of AI is my BI. So this is the basis of V. Fine. Then the last thing is you have to prove whether they are Li or not. Fine. How you can prove? The dimension is my n. Here n is my 2, so it constitutes the two elements. A1 and A2 are the basis. B1 and B2 are the basis. So this is also my basis. So again, all are my correct option by using this simple concept of the problem. Okay, look at this one. A is this, alpha, beta denotes the two eigenvalue. So we can find the eigenvalues of this. Trace, this is the trace of the matrix, and minus plus determinant of this. So determinant is my here. So can you find the value of this? B plus minus b square plus 4 over this. So you have the two values. One is my this and another is here. Fine. And absolute value of the alpha must be greater than of beta. So this value is my alpha. This value will be my beta. Alpha n is the eigenvalue of the alpha n. What is the eigenvalues of the a raised to power n? This is my eigenvalue of this a raised to power n. Fine. Now this value is called as my alpha n. This value is called as my beta n. Then look at the option. So first of all, we all know 1 plus root 5 over 2 is my greater than 1. So as n approaches infinity, this value alpha of n definitely goes to the infinity because this number is my greater than 1. Now look at this number. Now whether we all knows this number is my less than 1. Fine. But because it's a power of n, so what is that? If I consider this is my r, so what is the mode of r? This value is magnitude, is a root 5 is my 2 point something, and if I take subtraction, it will be minus 1 point. This is minus 1 point something. It is more than minus 1. It is more than minus 1. So if I take this power as infinity, again it goes to the 0 infinity because it is a here. Because we all know r raised to power n will goes to the 0 only when r is lies between 0 to 1. Otherwise it will goes to the infinity. Beta is a positive when n is even. So I can choose n is my 2. So then this value 1 minus root 5 over 2 raised to power square, because this number is my negative but the power is even, so this number is my positive. And when power is odd, this number is negative, so this number is also negative. All these options are my correct options. Look at this another one. V is a vector space of the dimension n. V is a 1 is the only eigenvalue. What is that? It means t is my I, which is not possible. You can see I can choose n is my 2. Fine. So you can see these are my here. If I consider this value, definitely this is not equal to I, and the eigenvalues are only my 1. First option cancel. Now look at this second option. Clearly says if I take n is 2, then it is my same option. Fine. So I can choose n is my 3. N is 3, it will be my 2. So I can change this example to be here. Again, this is not I. Okay, I can choose the one eigenvalues here. Now it are all eigenvalues 1 1 1. Now you can define any of the others, like say 1 1 1 for example. Then if I take n is 3, it will be my t minus square. So what is that? What is that? T minus of I? It is my 0 0 0. It is 0 0 1 1 1. Fine. So what is that? It is all the eigenvalues are 0. So what is that? T minus I of whole square. So clearly says it is a nilpotent matrix. This is my here. Fine. Now if you find this value, clearly says this value is my 1. These values are 0, but this value is non-zero, so it means this number is my non-zero. So this option is also cancelled. Look at this another one. Now they are talking about the n, and since dimension of this vector space is my n, what does it mean? T minus I of n will definitely be a 0. Why? because these are my characteristics polynomial. If I choose n is my 3, so what are the eigenvalues? 1 1 1. What is the characteristics equation? This is my characteristics equation, and characteristics equation satisfy this one, satisfied here. And how you can say? I can simply say this number is my of this, because this number is my 0, so this number is also 0. So the right answers are my C and D are my correct options. Okay, look at this another one. P3 is a polynomial of degree at most 3. At most 3 means equality there. So what is the dimension of P3 is 4. So this is 4, this is 4. So your target is to write as a 4 cross 4 matrix. Bases are 1, x, x square, x cube. Now if I take Px is my 1. So this value will be 1, this value will be 1. So it's a 2. So rest values are 0. If I take P of x is my x, this value will be x plus 1, this value will be, so it is a 2x. I can written as a 2, rest values are 0. If I take Px is my x square, this value will be x plus 1 square, x minus 1 square. So if I open this, it is my 2x square plus 2 and will be cancelled out. The constant will be 2, x square, it is my 2, rest values are my 0. If I take x cube, so it is my px plus 1 and x minus 1 cube. So what is that? It's a cube plus b cube plus 3a square b plus 3a square plus a minus b cube, a cube minus b cube minus 3ab minus 3a. Now you can see 1 will be cancelled, 3x square cancelled, so it's a 6x cube plus 6x, 6x, 6x cube, sorry 2x cube, it's my 2, rest are 0. So this is my matrix T. Now look at the determinant of this is 0. What is that? Eigenvalues are my 2, 2, 2 and 2. So what is the determinant of this? It's a 16, which is non-zero. First option cancel. 2 is the eigenvalue with multiplicity 4, is a correct option. Now of this, what does it mean? That we can find the minimal polynomial. Fine. If I found the minimal polynomial, that could be easy. What is the algebraic multiplicity of 2 is 4. Can I find the minimal polynomial? Means you can find the geometric multiplicity. So it's a 4 minus rank of a minus 2i. What is the rank of the a minus 2i? So it's a 0 0 2 0 0 0 0 6 0 0 0 0 0 0 0 0. What is that? Rank is my 2. So it is my 2. Fine. So what does that mean? Means characteristics is my x minus is my 0. But he said this is my non-zero. So this option is cancelled. Once this value is a 0, definitely x minus 2 cube is also be a 0. So but he said it's a non-zero. So this option also cancel. This option also cancel. Right option is only my D is the right answer. Okay, look at this one. R of n is a vector space of this. K is the kernel. Which of the following is there? Very simple. What is that? There exists transformation range and okay, we can apply the rank-nullity theorem. Rank of t plus kernel of t is my n. Rank plus nullity. The first option said both are same. So that means twice of this. What is the dimension is 5. So what is that? It means this value will be 5 over 2, which is not possible. There does not exist, yes, because it's a 2.5, but the dimension is always the integer, so there does not exist is the correct option. Now if it is a 6, now instead of the 6, what will happen? Because range and kernel are same, it will be my 3, which is a possible. Fine. If it is a possible, there exists, yes, there exists. He said does not exist, so this is the wrong option. So I will tell you the simple shortcut tips. Whenever the rank of the matrix or the kernel of the same, if n, that is a, what is that, dimension of this mapping is even. it only possible when this condition. You can see 5 is not a even, so this option cancel. 6 is even, this option satisfied. 5 is an odd, so there does not exist. There exists only when n is even. So that's why the right options are B and C are my correct options. Look at this another one. What is given to you? T is a mapping such that T2 circle T1. This is given to you where T1 and here. Then W is some finite dimension vector space and what does it mean that? If I assume both are my onto, what does it mean? Capital T is also my onto. Fine. What is the capital T? T is any mapping. Is it given that it's a onto? It is not given. So you can construct any of the mapping which is not onto. So definitely this option is cancelled. Similarly, both are my 1 1. If both are my 1 1, the composition is my 1 1, but it is again not given anything. So this option is also cancelled. T1 is onto, T2 is my 1 1. So it means now you can see this is my onto, this is my 1 1. Then definitely you can define that, because if this condition hold, or then you can say this is my identity mapping or any of them. So there exist them. So that's the correct option. Also either this is my 1 1 or this is my onto, then still there exists a mapping. So we can say C and D are my correct options. Okay, C capital T is the mapping over this. I can choose n is my, if I choose n is 2, then yes, fine. If n is 2, then 1 is the only eigenvalue. Then it is true for all the k. 1 is the only eigenvalue. Fine. What does it means? It is I. But he said t raised to power k is not equal to I. But if I choose k is equal to 1, then it's satisfied. This option cancel. Fine. Now look at this another one. T minus I. If I take n is 2, then he said t minus I will be 0. But if I choose this matrix, this is 1, this is 0. Clearly say it has only eigenvalues as a 1. But what is that t minus I, which is non-zero, because the matrix will be, which is a non-zero. So this option is also cancelled. Now what is that? If I consider a 2 cross 2 matrix, which is the diagonal value here, so eigenvalues are my 1 and 1, any number here, you can say 4 also. So what is the characteristics equation? X minus 1 whole square. So that means this satisfied. Once this equation satisfied, so I can return this number also as n into t minus I. So this number is a 0, 0 multiplied by something is also 0. So the right answer is my C and D are the right answers. Look at this another one. Firstly, I can choose n, and simple one is my 1. F is a mapping from R to R. F of 0 is 0. This condition, this implies summation 1, that is only x square is less than 1. What does it implies? Minus 1 here. So you can see this option is cancelled, this is cancelled, this here A is my positive, but we need lower limit as a negative. So the right answer is A is my correct option. So you can see very simple. You can take as a simple value and then you can get your answers. Okay, which of the following, let A is a 4 cross 4 invertible matrix, which of the following is not necessarily true? A is my 4 cross 4 invertible matrix. What does it means? Determinant is my non-zero. Fine. What does it means? If determinant is non-zero, what it means? Each row or column form a basis. Fine, because the columns are my Li if the determinant is a non-zero. So the row is my true statement. Null space, that is a kernel. So what is the rank of this matrix A? Rank of this matrix is my 4. So by the rank nullity theorem, rank plus nullity is my dimension. Dimension, remember, dimension is always the column vector. So this is my 4. So what is the nullity? Nullity is my 0. So it means the null space contain only is the 0 vector is the correct statement. But we need a false statement. Fine. A has a 4 distinct eigenvalue. It is not always true. If I consider that all the values are my 1, 1, rest values are 0. Like if I consider A is my identity, it is an invertible, it satisfies this property, but they have not the same. So this is my false statement. So this is the correct option. Image. Images means range space of this transformation is my 4. So we already proved rank is my 4 on the mapping Li vector to the set is Li vector. So this is my correct statement. Right option is only C is the right answer. Which of the following set is my vector space? Fine. Clearly says this is my not vector space. Why? Because 0 is not the part of S2. Fine. So only S2 cancel, all the are cancel. S1, because the 0 is satisfied, what is the vector space? You can simply prove, because the identity mapping is satisfied in the S1, that's a 0. Also f of x is my 0, so we can easily prove alpha of x plus beta of y is same as of this. Fine. Why? Because this number is 0, this number is 0, this is 0. So yes, this is a vector space. Here they are said the limit this exists. Fine. Whether it's a 0 or non-zero, there exists. Again you can see, if I say the limit exists for this, limit exists for this, limit exists for this, so in all this combination it is a vector space. So S1 and only S1 is the wrong option. C is my correct option of this example. Okay, suppose A is a 4 cross 4, the null space, that means they are defining about the kernel. Okay, very simple. Can you find the dimension of this null space? Because you can see I can return this is AX is equal to 0. Fine. How you can, this is AX is equal to 0. So what is the dimension of this? Number of the column vectors. Column vector is my 4 minus rank of this. How many free variables are there? You can see x plus y plus z is equal to 0, x plus y plus w is equal to 0. So here x and y are my dependent variable, while w and z are my free variable. Fine. So how many free variables are there? There are the 2 free variables, so I can subtract as here. Sorry, this is because this is here, so I can say dimension of this null space is my number of free variables. Fine. So number of the free variables are my 2. Now once you know the dimension of the free variable is 2, can you find the rank of the matrix? Rank of the matrix A is my dimension minus nullity. Fine. Dimension is always number of the column vector, minus nullity is my 2. So rank is my 2. What does means of the rank? So rank is 1, cancel. What is the meaning of the rank is? That is the dimension of the row space or dimension of the column space. Both have the same meaning. So it must be 2. So this is the correct option. This is the wrong option. Now these are the bases of the null space. When you can say it's a basis, if the points will satisfy the given equation. So clearly says this x plus y plus z is non-zero. It means this is not satisfied. If it is satisfied, you can check about these points. Both the points will satisfied here, but it is not satisfied. Right answer is only B is the correct option. Okay, T is the mapping from this given by here with the standard ordered basis. Fine. Very simple, because these are my Li. Fine. Now what is that? The first element will be my T of V1, because it's the basis. As I already told you, it's a mapping from A to B, then it start from the Li, it map on the Li. Fine. So this is my T of V2, this is my T of V3. So look at that. What is the T of V3? This is my T of V3, which is non-zero. T of, because it's a linear, I can open this as TV1 plus of TV2. If I add them, you can see it's a non-zero because of this 3, but he said 0. Again, I can open this, I can sum them, you can 0, 0, 0. So yes, it's a correct statement. V1 plus V3. What is the meaning of the V1 plus V3? I can V1, V3. Is it equal to V2? 1 plus 0 is 0, 1 plus 0 is 1, but V2 is my minus 1. They are not same. So the right answer is only my C is the right answer. Consider the two statement here. Which of the following statement is a false or not? Now they are the basis is given to you. I can apply the rank-nullity theorem. So rank of the matrix, rank of the A plus nullity of this is my dimension. Look at that. These are the basis of the row. Row means range. That is a rank. So what are the basis is? 2. Nullity is my 1. What is the dimension is? 4. Not same. False. Look at this one. 2. Nullity 2. Dimension is 4. Correct statement. So this is my, so second is my correct. First statement is false, second is correct. First is false, both are false, both are true. A is my right answer. Okay, look at this one. I can choose a simple n is my 3. So this equation becomes A3, A2, A1. Then the dimension of this, I can write this equation as of this form. Fine. Which is nothing but Ax is equal to 0 form. What is that? This is just look like say nullity. So you have to find the dimension of this one. How you can find the dimension? By using the rank-nullity theorem. N I consider as a 3 minus rank of this matrix A. So can you find the rank of this matrix? It's only the one equation. So it's a 1 cross 3 matrix and the rank will be my 1. So it is my 2. This is my 2 is the right answer. There is one more way, because you are talking about this nullity. How you can find the dimension of this nullity space? As I told you in the previous one, number of the free variables. On this equation, A3 minus A2 minus A1 is 0. So you can see A3 is dependent on the A1 and A2. So it means dependent variable is my 1, independent variable is my 2. So again you can see number of the free variable is my 2, so the dimension is my 2 is the right answer. A is my n cross n matrix of rank R. So the rank of A is my R. V is a vector space with a collection of all those matrices which is in the n cross n such that Ax is my 0. Fine. Then your target is to find the dimension of V. Or very simple. I will tell you the simple shortcut tricks. What is that? Whenever there is a collection of this, what is that? It's a nullity. Fine. So I can write it as a number of the column vectors n into dimension of nullity of A. Fine. How you can find the dimension of the nullity? Rank of the matrix, that is a dimension of A, dimension of this. So number of the column vector is x, n minus rank of this matrix. What is the rank of the matrix A? It is already given you as a R. So first option cancel, this cancel, n square R is cancelled, which is nothing but n square minus n. R is the right answer. Always remember, whenever there is a collection of the matrix which is again dependent on here, so this is a number of the column vector. If it is a nullity, you have to write the dimension of the nullity. V is a vector space of the polynomial with a degree less than 3. Remember, degree is less than 3. Equality is not there. So I can say this is a less than or equal to 2. But here, so what is the dimension of the V? Remember, it is not equal to 3 because it's a 2-dimension variable. So I can firstly give you the tips. Whenever you have the function of the variable x, y, z and so on, then dimension is always be the n plus number of the variables divided by combination of this, where n is the degree of the polynomial, var is a variable of this. For example, here this is x comma y with the degree is less than or equal to 2. So that means n is my 2. Here how many variables? Variable is also my 2. So then dimension will be 2 plus 2 over here. So 4c2. 4c2 means 4 3 over 2, that is my 6. So it has a 6 dimension. This is 6, this is 6. Fine. So you have to write a matrix corresponding to the 6 of the two variable 1 x x here. This is for the x, y, y square, xy. Fine. Then what is the transformation is partial derivative with respect to x. This is partial derivative with respect to x. If I take 1, partial is a 0. So all these 6 values are my 0. If I take x, partial derivative is a 1. 1 is a constant. Rest values are my 0. If I take x square, partial derivative will be my 2x. So coefficient of x is my 2. Rest values are my 0. Y, coefficient of the y is a 0. Because partial derivative y is a 0, I can written here. Y square, again a 0. What is the partial derivative of xy is? With respect to x is y. So this coefficient is my 1. Rest all are my 0. Now look at the options. First of all, T is my invertible. Clearly says what is the rank of this matrix T. How many non-zero rows? 1, 2, 3. Rank is my 3, which is less than of 6. So T is invertible, cancel out. Moreover, if you look about the eigenvalues, all these eigenvalues are my 0. So what is that? It's nothing but my nilpotent matrix. Fine. And it is a not invertible. Moreover, nilpotent matrix is not diagonalizable. Fine. But they are not talking about. The rank of the matrix is at least 3, greater than or equal to 3. So is equality 3. Equality is satisfied here. Rank is at least 4. But 3 is not satisfied, cancel out. Now you can apply the rank-nullity theorem. Rank plus nullity is my here. So nullity will be 6 minus rank. So it's a 6 minus 3 is my 3. At least 3. At least 3. Again equality will be here. So the right answers are my A and C are my correct options. V is the vector space in the two variables over the real dimension of degree at most. At most means L is appear. The same I can apply this rule. Fine. So what is the n? Number of the variables. Number of the variables. Sorry, degree is my L. Number of the variables is my 2 because it's a 2 variable. So L plus 2 combination of variables. Variable is my 2. So how you can do that? L plus 2. L plus 1 over 2. So L plus 1, 2 is the right answer. Now it's a June 2023 question. V is a polynomial of degree at most 10. That's a less than or equal to 10. So what is the dimension of the V? It's a single polynomial. So you can say as 11. Again, you can apply this rule again. What is the n? What is the degree is? 10. Number of the variable is 1. So it is a 11C1 is a 11. Then we can define this. So what is that? It's my V cross V. So it's a 11 cross 11. I can written as a 1 x square up to x raised to power 10. Fine. Now the transformation is my derivative. If I take 1, it is my 0. If I take x, derivative is a 1. So it's a 1. If I take x square, derivative is my 2x. So the coefficient of this is my 2. Rest all values are 0. If I take x cube, the derivative will be my 3x square. The coefficient of the x cube, that is the third element. Here rest values are my 0. Similarly, if I take x raised to power 10, derivative is 10x raised to power 9. So it's a 10, rest values are my 0. So clearly says this value will be my here. Clearly says again it is my diagonal values are 0. All those eigenvalues are my 0. If all eigenvalues are 0, it means the determinant is my 0. If all those eigenvalues are 0, the trace of the matrix is the sum of the eigenvalue is also the 0. Rank is my 10. It's a 11 cross 11, and you can see one of the eigenvalues is 0, the last row is 0, so the rank of this matrix is my 10 is the right, because only one non-zero rows is there. So you can see all are my correct option, and this is a recent year examination. Okay, look at this one. T is a mapping, is a linear transformation the R cube. Fx is a characteristics polynomial. Consider the two statement. T is my non-zero. 1 is the eigenvalue. One eigenvalue is 0. Fine. So it's a 3 cross 3. One eigenvalue is my 0. Such that f of x is my here. So other eigenvalues are my say alpha and beta. So what is the characteristics equation? X minus alpha, x minus beta. Fine. This is my characteristics equation. So if you compare, this is my g of x. Fine. Now then g of t is also my 0. Fine. So what is the g of t? Because alpha and beta are unknown, so definitely alpha and beta are my non-zero, because he said one eigenvalue is my 0. Okay, one eigenvalue is my 0. It may be 0. Okay, if I choose alpha is 1, beta is my minus 1. So this equation becomes my x square minus 1. What is the g of t? Is a t square minus I. What is the eigenvalues of t? 0, alpha, beta. So that's a 0, 1, minus 1. What is the eigenvalue of the t square? 0, 1, 1. What is the eigenvalue of the t square minus I? T square has eigenvalue this, minus eigenvalue of the I matrix is 1, 1, 1. So the eigenvalues are minus 1, 0, 0. So what is that? This matrix will be becomes my minus 1, 0, 0. So clearly says that this is my non-zero, because one of the eigenvalues is non-zero. The first option is my false statement, but he said correct. 1 cancel. Suppose 0 is the eigenvalue with at least two linearly independent eigenvector. Linearly eigenvector, that means geometric multiplicity of the 0 is my 2. Fine. It means one of either alpha or beta is also 0. So what is that? It is my x square, x minus alpha. Now if I compare this, what is my g of x? G of x is my x into x minus alpha. Now I can choose, alpha can be any number, but it said at least is there. Fine. So it means alpha can be 0 or alpha is non-zero. If it is non-zero, I can assume 1. If alpha is 0, assume that. Then what is the g of x? G of x is my x square. Fine. And the algebraic multiplicity is my 0, so definitely g of t is my t square is my 0. So then it's a correct. But what about this? Then what is my g of t? It's my t square minus t. Fine. So what are the eigenvalues of t? There are two eigenvalues 0, one eigenvalue is my 1. So this is 0, 0, 1. What is the eigenvalue of the t square? 0, 0, 1. So what is the eigenvalue of the t square minus of t? 0, 0, 0. So if all those eigenvalues are my 0, that means this is a nilpotent matrix. So this value is also my 0. Hence this is my correct statements. Only second is my correct option. Rest are my wrong option. Okay, look at this another one. what is given to you? B is a 3 cross 5. Okay, you can see what is a B by 0 means. They are talking about nullity. So what is that? Nullity of the B, what is given to you, is a 3 dimension. So nullity of B is my here. Can you find the rank of this? It is this minus, what is the dimension? Number of the column vector. Always remember the column vector. So what is that? Rank is my 2. Fine. So rank is my 2 means column span of the B is my 2 dimension is the correct option. Now look at that. What is that? V is the element of the R raised to power 5. B is the elements of the Q. Here you can see what does it means. It has some elements. Fine. Into V is my 0. V is the element of the R power 5. But there is, you can see what is the difference between them. There is only on the changes of the V, but there is no change in the capital B. So these are same. So what is that? This is also the same as of, what is that? It is also the nullity. Fine. So what is the nullity of the B? Nullity of the B is 3. So it's a 3 dimension. Now the next one is your target is to prove injective, that is a 1 1. How you can prove the injective? Your target is to prove kernel of this value must be 0. Fine. So for that I have to firstly find the range of B transpose. So what is the rank of the B transpose? We all know rank of the B and the rank of B transpose are same. So what is the rank of the B? 2. Number of the column vectors, its matrix is, its matrix will be 5 cross 3. So now you can apply this rank, nullity of the B transpose. Rank of the B transpose must be my 3 dimension of this. So rank of the B and the B transpose is same. It is my 2. So what is that? This is my 1. So but which is non-zero. So that means it is not 1 1. So this option is cancelled. Look at this one. Your target is to prove this is injective. It means your target is to prove kernel of B and B transpose should be 0. So I can start from the rank. What is the rank of the B into B transpose? Which is same as of the rank of B, which is same as of the rank of the B transpose, which is of the 2. So therefore rank of B into B transpose plus kernel of the nullity of the B into B transpose is my dimension. Dimension is my 3. So what is the value of this? It is my 1, which is non-zero. It means it is not 1 1. So A and C are my correct options. Okay, look at this another one. P10 is a polynomial of degree up to 10 including 0. Okay, so what is the dimension of P10? It's 11. V1 is a vector space of all the polynomial of degree of all those polynomials which is of P of 5. So what is the dimension of W1? 6. W2 is all those subspace of the polynomials of all those polynomials of P of 10 such that sum of the coefficient will be 1. Sum of the coefficient means f of 1 will be. So can you find the dimension of W2? So dimension will be 11 minus, there is only one condition, so it's a minus of 1. Fine. Then dimension of the intersection. How you can find the dimension of the intersection? So we all know dimension of intersection. So firstly you can find the intersection. This is my here, this is my this. So what is that? What kind of the polynomial of degree 5? This is the degree 10. It is my degree 5 such that condition will be fine. So what is the dimension of this? Degree of this is 6 minus 1 condition, that is my 5. So once is a 5, it's at most 5, that's the correct state. Now look at this third option, W1. You can choose any polynomial in the W1. W1 is a degree of polynomial 5. I can choose as a x5 plus x. This is the W1. Does it belongs to the W2? What is the W2? W2 is the polynomial of degree 10. Yes, it's a polynomial of degree 10 also, such that f of 1 is 0. Is it f1 0? F1 is non-zero, so it means this does not belong to this. But if I consider this example, this is my w1, then clearly says f of 1 is my 0, which is the part of w2. But one counter example is we can here. So what does it mean? This w1 does not contains in the w2. Let w is the smallest subspace of the w1 and w2. What is the smallest subspace? How you can define the smallest subspace? The smallest subspace is my w1 plus w2. Then your target is to find the dimension of this. So we all know what is the dimension of the w1 plus w2. Dimension of w1 plus dimension of w2 minus dimension of their intersection. So what is the dimension of w1? 6. Dimension of w2? 10. This we already computed as a 5. So it's my 11. But he said at most cancel. What is the v? Oh, this is v. V is equal to polynomial of this. So dimension of w is my 11. Dimension of v is my 11. So both the dimensions are same. On the finite dimensions they are same. So B and D are my correct option of this problem. Look at last example here. If capital T is a mapping over the R cube to this such that, what is the characteristics equation? This minus 3x square plus of 2 will be 0. Fine. Which of the following is my, there exists symmetric upper triangular here. So we need to find the eigenvalues. So clearly says 1 is the eigenvalue. So x minus 1. How you can find? I can quickly apply the Horner method. X cube, x square, 0, constant. So 1 is the root. So I can solve this. It's a 1. It's a 1. I can apply the Horner method to, so, or otherwise you can divide them. You can divide this. Fine. Otherwise you can apply the Horner method. It's a minus of 2. So it's a minus of 2. It's a 0. So this one will be x square minus 2x minus of 2 is my 0. So the one eigenvalue is my 1. Other from here I can find that 2 plus minus b square plus 4ab over 2. So what is that? It is my one eigenvalue is 1. It is a 1 plus minus. It's a 12. It's 1 plus minus here. So what is that? 1 plus root 3, 1 minus. So what is that? They have the distinct eigenvalue. So once they have the distinct eigenvalue, it means the matrix capital T corresponding to this transformation is my Diagonalizable. Once it's a Diagonalizable, we can write this value as the first eigenvalue, second eigenvalue, third eigenvalue. It is my 0. So clearly says this matrix is my symmetric. There exists, yes, you can construct a there exists is a symmetric. So first is the correct option. Is the upper triangular? Yes, you can construct a upper triangular. Fine. So first and second are correct options. There exists a non-zero vector v such that of this. What is the meaning of that? 1 is the eigenvalue and we already obtained 1 is the eigenvalue. So third is also the correct option. There exists a 2 Li vectors such that this and this. It means 1 occurring 2 times. But the multiplicity of the 1 is only 1. So the right answers are A, B and C are my correct answer of this problem. So this is the way you can solve the linear transformation. Always remember, you can pick about the basis, construct the matrix and then make the decision. We will see the next lecture on the gate complex analysis question as per your request. Till then, you can simply scan and join my WhatsApp group. You can share, like and comment on my video. Best of luck students. Happy learning.